Fellow mathematicians, today we're going to be learning about two-step equations. We're actually going to continue from last time. So here I have the problem x minus 5 divided by 2 is equal to 12. Now normally if we knew the value of x, we would do whatever number that was minus 5 divided by 2 and then we would get 12. But we don't know the value of x, so we're going to have to work backwards in order to figure it out. So we want to isolate our x. So for working backwards, we see that x minus 5 is all being divided by 2. And in order to get x by itself, the first thing we're going to do is, because this expression here is being divided by 2, we're going to multiply by 2. And multiplying by 2 actually cancels these out because multiplication is the inverse operation of division. And since we multiplied by 2 on the left side, we're going to multiply by 2 on the right side. So now since these two canceled out, all I'm left with is x minus 5 is equal to, now I have 12 times 2, which is 24. So now I have x minus 5 is equal to 24. And remember, our goal here is to isolate our x value. So what I could do here, since it's x minus 5, I could actually add 5 on both sides. And that cancels the minus 5 out. And then add 5 here because we want to keep our equation balanced. So whatever we do to one side, we do to the other side. So after we cross these out, I have x equals, and 25 plus 5 is 29. Now, if we want to go back and check our work to see if we did this correctly, we're going to go back and substitute for x. So instead of x minus 5, we're going to have 29 minus 5 divided by 2. And now 29 minus 5 is 24. And 24 divided by 2 is 12, and that's what our equation was equal to, so that is a true statement. So that's how we know x is definitely equal to 29. So in this problem here, it's very similar as the one on the slide before. We have x minus 3 divided by 2 equals to negative 9. Same thing as before. If we want to get the x minus 3 by itself, we're going to multiply by 2. Since x minus 3 is being divided by 2, so that cancels out, and whatever we do on one side, we do on the other side. So we're going to multiply by 2. So now on the left side, I'm left with x minus 3 is equal to, and on the right side, I have negative 9 times 2, which is equal to negative 18. So now I have x minus 3 is equal to negative 18. And remember, our goal is to isolate the x. If I want to get rid of minus 3, I'm going to have to add 3 on both sides. So these two cancel out because they're inverse operations. I have x is equal to, I have negative 18 plus 3. So because the signs are different, I'm going to subtract, and I get 15. And then I keep the sign of the one that has the biggest absolute value, which is negative 18. So my answer is going to be negative. And then if I want to go back and check, all I have to do is substitute x for negative 15. So negative 15 minus 3 divided by 2. Negative 15 minus 3 is negative 18. Divided by 2 equals negative 9, and that's true. So x is equal to negative 15. So here I have another problem. So I have 2 times x minus 5 equals to negative 14. And there are two ways that we could go about solving for x in this case. So the first way is, we know we have the distributive property here. So the first thing I could do is distribute if I wanted to. So 2 times x is 2x. 2 times negative 5 is negative 10. And that equals to negative 14. Please do not distribute the 2 to the negative 14 because we're only going to distribute to whatever is inside the parentheses. So now that I have 2x minus 10 is equal to negative 14, that looks very similar to two-step equations that we've been working on. So to isolate our x, the first thing we'd have to do is add 10 on both sides because remember, we want the 2x last. So if I add 10 on both sides, these two cancel out. And on the left side, I have 2x is equal to negative 14 plus 10. Remember, if the signs are not the same, we subtract. So 14 minus 10 is 4. And we keep the sign of the number with the biggest absolute value, which is 14. So here we have negative 4. And so now I have 2x is equal to negative 4. In order to get x by itself, I'm going to have to divide by 2 on both sides. So 2 divided by 2, remember that's 1. 1x is the same as x. So I'm going to just write x. And then negative 4 divided by 2 is negative 2. And that's it. Later I'm going to come back so we could check this answer. And another way we could go about solving this is we know that we have 2 times x minus 5 is equal to negative 14. Now, instead of distributing, because we're multiplying here, we could divide by 2. And by doing that, these two cancel out. And I'll have to divide by 2 on the other side. So now on the left, I have x minus 5 is equal to negative 7. And my goal again is to isolate my x. So what I'll do is I'll add 5 on both sides. So now I have x is equal to negative 7 and positive 5 are opposite signs. So we're going to subtract them. 7 minus 5 is 2. And we keep the absolute value, we keep the sign of the one with the greatest absolute value, which in this case is 7. So it's negative 2. So we did get the same answer for both of these, which means that most likely our answer is true. But it's always good to go back and confirm by substituting in our x value. So if I go back and substitute our x value, it's going to be 2 times negative 2 minus 5. And so I'm going to do negative 2 minus 5 first. So 2 times negative 7. And that is equal to negative 14. And that's how we know we got our problem correct. So here I have another problem that is very similar. Again, you could choose which way is easier for you. I am going to show you both again, just so that I know that you're comfortable with both. But you could honestly pick whichever one is easier for you. So again, the first thing we could do is we could actually distribute. So negative 3 times x is negative 3x. Negative 3 times 5 is negative 15, so in this case we'd write minus 15, is equal to negative 12. Please do not distribute the negative 3 to the negative 12. Now I have negative 3x minus 15 is equal to negative 12. So our goal is to isolate x, so we're going to add 15 on both sides. And this cancels out. We're left with negative 3x is equal to, now we have negative 12 and positive 15. The signs are different, so we're going to subtract. And if we subtract, we get 3. And if we keep the sign of the number with the biggest absolute value, it's positive, so I could leave it just as you see it. So now we have negative 3x is equal to 3. What we could do is divide by negative 3 on both sides. So x is equal to 3 divided by negative 3 is negative 1. And that's it. So the other way we were introduced is if we had negative 3 times x plus 5 is equal to negative 12. Remember that this is multiplication, so we could divide by negative 3 and that would cancel out. whatever we do on one side, we do on the other side. So we divide by -3 here. And if you guys look at our previous problem, we did end up dividing by -3, just not at the very beginning. So that's how we know it's the same thing. And then I'm left with x plus 5 is equal to -12 divided by -3 is positive, so positive 4. And now I have x plus 5 is equal to 4. In order to isolate our x, I'm going to have to subtract by 5 on both sides. And these cancel out. So x is equal to 4 is positive, 5 is negative. Remember, when the signs are opposite, we subtract. And then we keep the sign of the one with the biggest absolute value, which is 5. So -1. And if we wanted to go back and check our work, all we would have to do is substitute. So -3 times -1 plus 5. And then that's -3 times -1 plus 5 is 4. And -3 times 4 is -12. So that is correct. All right. Here we have some word problems that we're going to go over. The first one is Jessica has X beads in her kit to make bracelets. She buys an additional set of 54 beads and divides her total beads evenly among herself and 2 friends. If each friend received 102 beads, how many did Jessica start off with? So we know that Jessica has X beads, and then she bought an additional 54. And then once she did that, she divided her total beads evenly amongst herself and 2 friends. So that's a total of 3 people. And then after she divided her beads up amongst everyone, we know that each person received 102, meaning she also stayed with 102 beads. So here, what we're going to do first is we have x plus 54 divided by 3 is equal to 102. And in order to make this a little bit easier, we can multiply by 3 so that this cancels out. So we're going to multiply this by 3. And now we have x plus 54 is equal to 102 times 3 is 306. And now if I want to isolate our x, we're going to have to subtract both sides by 54. So -54 minus 54. This cancels out. X is equal to 6 minus 4 is 2. Going to cross this out, make this a 10 and borrow from the 3. 10 minus 5 is 5, and 2 minus 0 is 2. So she initially started off with 252 beads. She bought 54 more, which then she had 306, and then divided those 306 beads amongst 3 people, including herself, and everyone ended up with 102 beads. So if we wanted to check our answer, 252 plus 54 divided by 3, so 252 plus 54 is equal to 306, which is the total number of beads she had after she bought some more, divided by 3, so that's the number of people, and then that gives us 102 because everyone got 102 beads. And that's how many Jessica started off with. So in our next problem, Brandon bought X candies. After eating 3 candies, he divided the remaining candies evenly amongst 4 friends. So if each friend received 5 candies, how many did he start off with? So we know that Brandon bought X candies, so we don't know how many he had to begin with. And then he ate 3, so we're going to take away from the total amount that he bought because he ate them. And then he divided the remaining candies evenly among 4 friends. Now, unlike the problem that we had before, here he's dividing them among 4 friends. And the previous problem, it said she was dividing the beads amongst herself and 2 friends. So here he's just giving the candies out to his friends. He's not keeping any for himself because he already ate 3. So if each friend received 5 candies, how many did he start off with? So after he ate 3 and after he divided it amongst his 4 friends, each friend ended up receiving 5 candies. So to start this problem, we have x minus 3 divided by 4 is equal to 5. So since we're dividing by 4 here, we're going to multiply by 4 to cancel this out. And then whatever we do on one side, we do on the other side to keep it balanced. So we multiply by 4. So x minus 3 is equal to 5 times 4 is 20. And so we have x minus 3 is equal to 20. We're going to add 3 to cross this out. And then plus 3 because we want to keep it balanced. So x is equal to 23. And so he started off with 23 candies. So let's just double check here. So if he started off with 23 and then ate 3, he had 20. And then he divided it amongst 4 friends, meaning that each friend gets 5. So he started off with 23 candies. All right, so Alex and his friend each bought 3 bags of chips and a soda. Their total cost was $22. If the soda cost $2, how much did each bag of chips cost? So Alex and his friend each bought 3 bags and a soda, and we don't know how much the 3 bags cost, so we could just write 3x. And they also bought 1 soda, but we do know how much the soda costs, so we're going to put plus 2. And since there's 2 friends, we're going to multiply all of this by 2. So here we have the 2 friends that each got 3 bags of chips because we don't know the cost, so that's x, and a soda, which was $2. So their total cost was $22, and we want to figure out how much each bag of chips cost. So we could do this one of 2 ways. I'll actually do this the second approach because I find that to be easier, where this is multiplication and we're going to divide by 2 to cancel this out. If you want to distribute first, you're more than welcome to do so. So divided by 2 here. So now we have 3x plus 2 is equal to 22 divided by 2 is 11. And so here we have 3x plus 2 equals 11. We could subtract by 2 on both sides. That cancels out. We're left with 3x is equal to, now 11 minus 2 is 9, so 3x is equal to 9. And we could divide by 3 on both sides. 3 divided by 3 is 1x, so x equals to 3. So each bag of chips cost $3. And we could go back and check our work. So 2 times 3 times, so I'm gonna write a parentheses times 3 plus 2 equals to 22. So here I have 2 times 9 plus 2, which is 2 times 11, which does equal 22. So this is correct. So each bag of chips costs $3. All right, so here's our last question. Laura and her two brothers went shopping for school supplies. They each needed 5 notebooks and 4 pencils. Each pencil cost 50 cents and their total cost was $36. How much did one notebook cost? So here we have a lot going on, so let's take it one step at a time. So Laura and her two brothers, that's a total of 3 people. And they each needed 5 notebooks and 4 pencils. So 5 notebooks so 5x since we don't know how much it costs, and 4 pencils each, but we know that each pencil costs 50 cents. So 4 pencils at 50 cents per pencil, that ends up being $2. So each person here, so Laura and her two brothers, needed 5 notebooks and 4 pencils, and the 4 pencils cost $2, and their total cost was $36. So all 3 of them bought 5 notebooks and $2 worth of pencils, which gave them a total of $36. And so here you could go about it one of 2 ways. You could either distribute or divide by 3. So since we divided by 2 in this problem, I'm going to distribute here. So 3 times 5x is 15x. 3 times 2 is 6 is equal to 36. So what we're going to have to do first is subtract by 6 on both sides. So 15x is equal to 30. And if I divide by 15 on both sides, x will equal 2. So that means that one notebook costs $2. So let's go back and check. And again, I'm just substituting in for x. So let's see if that's true. So we end up with 3 times 12, which is 36, so that is correct. So each notebook costs $2. And that's it.